Alright, so today we're going to start out with WHS Juniors average 1752 on last year's SAT, and the standard deviation was 25. This year we're going to know if it's going to be any different, so we take a random sample of 30 students and we got a score of 1760. Now we want to know if there's a difference. So we're going to do a hypothesis test. So my population is all WHS juniors. And the parameter is average SAT score for all juniors, and I'm going to erase myself a little room here, so parameter, and I want to make this mu equals, because we're trying to figure out whether mu would be the same. And so my two hypotheses, my first hypothesis is that it did not change, and my second is that it did change. So it's not equal 1760, because that's just, it's that it's not 1752. And this is called a one sample z-test, because we are given the sigma for the entire population and we're doing a mean, not a proportion. So the next part is conditions. SRS is stated. Independence, we got 30 times 10, which is 300, which is less than the total WHS juniors. And for my normality, I did 30, which is the perfect amount for us to use the central limit theorem to say that it is approximately normal. So the third thing we're going to do is we're going to try and do our calculation. So my expected value for X bar is what I put up there, which is 1752. My standard deviation for X bar is, let's see, 25 divided by the square root of 30, and that is 4.56. So here's 1760 equals X bar, and here it is on the other side. Well, not 1760, but because we're doing two tails, this area and this area are both going to be in my p-value. So first I need to find out what z is. Z is 1760 minus 1752 divided by 25 over the square root of 30, because that's my standard deviation. And I get 1.75. So we are looking for the probability that z is bigger than 1.75, or the probability that z is less than negative 1.75, since this is symmetric. So I'm going to use my normal CDF to get the answer. And when I do one side, it turned out that this was simply 0.04, but I'm going to multiply it by 2 because I have both sides. So in my picture, this is 4% and this is also 4%, to give me a p-value of 8%. So now let's take a quick look at what would happen if this was a one-sided. So in here, let me get a different color. So the purple will be all the changes that I'm going to make for this problem. So is there a difference? I'm going to change this to did we improve? So the population would still be the same. The parameter would still be the same. But if we're trying to do if we improved, I would do mu is greater than 752. So that's my first change. Then the one sample z-test stated. This part is the only part I would shade in, so I wouldn't have to worry about anything else. My z-score would be the same, but I would just do the probability that z is bigger than 1.75, and we simply would have gotten an answer of 0.04. And so this, the fact that we only shaded in one side, and the fact that we changed our alternate hypothesis is the only thing that we would have changed if we changed the question to did we improve. And that's going to be it for this particular lesson.